SQA National 5 Application Maths 2019 Paper 2 Question 1. Sam buys a rare stamp for his collection at auction and he buys the stamp for £920. It increased by 7% in each of the first 2 years, decreased in 4% for the third year. Calculate the value of stamp after 3 years. So this is appreciation and depreciation. So for the first bullet point, I've got 7%. So I need to work that out as an appreciation. So that becomes 107% adding from 100, which is 1.07. And it's for 2 years, so that's going to be squared. If for the next bullet point, I'm taking away from 100. 100 minus 4 is 96. So that's 96%, 0.96, and that's just for a year. So to work out his price, it's 920 times 1.07 squared times 0.96. And that gives us 1011.175 with a bunch of other numbers, but we have to round it to 3 significant figures. So that means I round it to the third number, which is here. So that's 101, and then 0 for the last position up to the decimal point. And we're done there. SQA National 5 Application Maths 2019 Paper 2 Question 2. The bottle consists of a cuboid and a cylinder. The dimensions are shown in the diagram. Calculate the volume. So we've got a volume question here. We need to be able to calculate a cuboid ourselves without any work. But for a cylinder, we can check the start of the exam paper. So volume of a cylinder is pi r squared h. And for a cube, it's just length times breadth times height. Or cuboid, sorry. Length times breadth times height. So we need to work out those two separately, then add them together. So let's check that we have everything we need. For a cuboid, we've got 10, 8 length, 4.5 breadth for going in the way, and 10 high. So we're timesing them together. And for our cylinder, it's pi times, now we need to work out what r is. Well, we know the diameter is 3, so r is half the diameter, so r is 1.5. So 1.5 squared. And then times by the height of the cylinder, which is 4. So let's work out our two sums separately. So volume cylinder, pi times 1.5 squared times 4 is 28.274. Not going to round too much, but that will do there. And then the volume of a cuboid, 8 times 4.5 times 10 is 360. So our total volume, writing down our sums, 28.274 plus 360, but using a calculator to work that out, I get 388.271 centimetres cubed for the units. You could round it if you want, but it's not asking you to. But 388.27 or 388.3 centimetres cubed would be fine as well. And we're done there. SQA National 5 Application Maths 2019 Paper 2 Question 3. The graph shows how many pounds sterling can be bought for €1 during December 2017. Daniel changed €250 to pounds at 9 o'clock on the 7th of December. How many pounds did he receive? So we need to identify where 9 o'clock on the 7th is. There it is there. And we need to identify the exchange rate. So being careful, we read that correctly. Go up to here. So on 0.85, and then it goes something, 0.86. So it's going up in twos because there's 5 divisions. So it's 0.852 at that point. So that means that we've got 250 times 0.852. That is €213. Daniel was working in France. He bought a laptop costing €400. He calculated this was equivalent to 334.80. Use your graph to find the date he bought the laptop. So if we had €400, we would times by an exchange rate and get 334.80. So if we go backwards from there, 334.80 divided by 400 will give us the exchange rate. Or if you don't like that, you could just take 400 and times by each of these exchange rates until you get the correct answer. I'm going to do it the quick way. So to work out the exchange rate, I'm going to do 334.80 divided by 400. In a calculator, that gives me 0.837. And now all I need to do is go back up to here. So 0.837, I need to find on the graph, well, I've got 0.83, 832,468. So 7 is going to be between these two. So we can see that here, 0.83, 83246, that'll be 837. So I can read that date off the graph, which is the 9th of December at 9 o'clock. So we can just put that down. 9th of December at 0900. And we're done there. SQA National 5 Application of Maths 2019, Paper 2, Question 4. Karen buys and sells silver, gold and platinum. The table shows the price per ounce for each of these metals on the first trading day of each month over last year. Karen bought 1 ounce of gold on the first trading day of March and sold it on the first trading day in September. March, September. Calculate the percentage loss she has made. So we need to find gold. So let's look on our table. There's the price of gold, so not silver. She bought it on the 1st of March, so March in gold is 12.10. So first of all, we take a note that in March it was 12.10, and then we go to September, and it was 11.40. So in September, it was 11.40. So calculate percentage loss you made or a fraction loss. So we need to do the difference divided by the original amount. So I'll do 12.10 minus 11.40. So that means she lost 70 out of 12.10, which she had originally. So our loss as a fraction is 70 out of 12.10. But to change that to a percent, we times it by 100. So in a calculator, that is 70 out of 12.10 times 100, 5.785%, or to 2 decimal places like I asked you to, 5.79%, and we're done there. SQA National 5 Application of Maths 2019, Paper 2, Question 5. A hotel is having a swimming pool built. It is in the shape of a rectangle and 2 quarter circles as shown below. The swimming pool will have a safety rail fitted around the edge. Around the edge is perimeter. There will be 2 125cm wide gaps to allow access to the pool. The safety rail is sold in 3 metre lengths. Each 3 metre length costs $11.49. Calculate the minimum cost of the safety rail of the pool. So I'm going to have to work out the perimeter, but then leave a gap of 2 times 125. So perimeter of semicircles, well, we can do the circumference of a semicircle because we get a circumference of a circle in the exam paper. Circumference of a circle from the exam paper is pi times diameter. I've got 2 quarter circles, so that's 1 semicircle. So for my circumference part, it's a half times pi times the diameter. Now I need to calculate the diameter. This tells me from here to here is 10, but that's a radius. So the diameter is 20. So the circumference part is 0.5 times pi times 20, which is 31.4159. So we've done this bit and we've done this bit. So now we need to add on the straight bits. Well, we know that this is 36.5, so is this bit. So I can add 2 36.5s, so let's just take a note of that. Plus 36.5 plus 36.5, I'll just call this the perimeter. And then I need to add on these 2 bits here, but since this is a circle, they're a radius, so that's just 10. So another 10 and 10 here. So that's 10 plus 10. So in total, I have got 31.4159 plus 36.5 plus 36.5 plus 10 plus 10, 124.4159 meters. But it then says there'll be two 125 centimetre gaps. So take away the gaps. Now you can't take away 125s because that is centimetres. So I'll change that to metres, which is 1.25 divided by 100. So I'm doing 124.4159 minus 1.25 minus another one because there's two gaps. 121.92 to two decimal places. So now we know the whole length we need, and we move on to the next bit, working out the cost. So it says the safety rail was sold in 3 metre lengths. Each 3 metre length costs £11.49. So I need to work out how many bits of safety rail. So number of safety rail, that's just going to be 121.92 divided by 3 because they're sold in 3 metre lengths. So 121.92 divided by 3 equals 40.64. So you're going to have to buy extra because you can't buy 0.64. So you need to buy 41. Then the last bit, each 3 metre length costs £11.49. So I need to do, for the cost, £11.49 times 41. And that gives me £471.09. And we're done there. Let's go in Answer 5 Application Maths 2019, Paper 2, Question 6. Denise bought 375 shares for £4.50 a share. She later sold them for £5.20 a share, and she had to pay 2.7% of the total selling price for commission. Calculate her profit. So we need to work out how much she bought them for. So looking at the bought price, we did 375 times 450 a share. So that's a calculator job. That gives me 1687.5, 1687.50. So that's what she bought them for. And then in terms of sold them, we've got £5.375 times £5.20. 375 times £5.20 is 1950. Normally that would be your profit, the difference between these two numbers, but she has to pay 2.75% of the selling price. So I need to work out 2.75% and take it off. So 2.7% of 1950. That gives me 52.65. So that means that her profit is simply 1950 minus 52.65, because that means that's how much she actually made, and then take away how much she sold them, bought them for originally, 1687.50. 1950 minus £52.65 minus 1687.50. That is a profit of £209.85. And we're done there. SQA National Fire Application Maths 2019, Paper 2, Question 7. The birth weight of babies in a hospital in 2017 was recorded. A sample of weights in kilograms is shown. Calculate the mean and standard deviation. Quite standard stuff here, so I add them up and divide by how many will have for the mean, and then I use the formula sheet to help me do my standard deviation. And I'm up 2.5 plus 4.5 plus 3.7 plus 3.1 plus 3.8 plus 3.4. That gives me 21. So the mean is the total, which is 21 divided by 1, 2, 3, 4, 5, 6. Using a calculator for that, divide the answer by 6, and you get 3.5. Units technically are kilograms. So now standard deviation. Start of exams paper tells you that the standard deviation is the square root of the sum of x minus x bar all squared over n minus 1. Now there is another formula you can use, but I always use this one, so that's the one I'm going to show you here. And the way I remember this is I draw a little table, like so, being as neat as I can. And that's my x. And then top of the formula, x minus x bar, and then x minus x bar squared. So as I'm doing this table, what I'm trying to do is get to the last number here, and I'm going to add all them up, and that just becomes the top of my formula, because that means the sum of, which is added all up, add up all the x minus x bar squared. The last thing you need to realise is x bar means the mean. So in the middle here, I'm doing each number take away the mean. So let's note down the numbers: 2.5, 4.5, 3.7, 3.1, 3.8, and last 3.4. So there's all my numbers. So I'm going to take away 3.5 from each of them. Now, use a calculator at any time, but I'm going to do it quickly. So that's minus 1, and that's 1. That's 0.2. That is 0.4 minus. That is 0.3. And that is minus 0.1. And I square each of my numbers. So in the calculator, minus 1 squared is 1. 1 squared is 1. 0.2 squared is 0.04. 0.4 squared is 0.16. 0.3 squared is 0.09. And 0.1 squared is 0.01. And then I get a total, add all them up. 1 plus 1 plus 0.04 plus 0.16 plus 0.09 plus 0.01 is 2.3. So there's my total there. So that means that at the side I can work out the standard deviation now. It is simply the square root of the number I just found out, divided by, well, n minus 1 means 1 less than the number of numbers you started with. I started with 6 numbers, so it's divided by 5. Now notice I'm square rooting the whole of that, so I need to use brackets in my calculator. So I get my calculator out, press the square root button, bracket, 2.3 divided by 5, and then close the bracket so it squares it all. I get 0.678. A bunch of numbers. Now you can round or not round. I'm just going to round that to 0.68. And we're done there. So we now get to our standard statement questions. The birth weight in babies born in hospital in 1987 was also recorded, and the mean in 1987 was 3.4 kilograms, and the standard deviation was 0.95 kilograms. Make two valid comparisons about the weight of babies in 2017 and 1987. So let's compare the mean first. The main thing with the mean is you're always starting off with on average. And then I'm just checking which one was bigger. So they got 3.4 and I got 3.5 for 2017. So on average, the weight of babies in 2017 was bigger. And you can see why. That's because 3.5 is bigger than 3.4. And then standard deviation is about consistency, how spread out or consistent the weights are. So what you do is you look at my number, which is 0.68, and theirs is 0.95. So the weights of babies in, I'll take the lower number, 2017 again, was now more consistent, means a smaller standard deviation. So I've got 0.68, they've got 0.95, so more consistent. And that's because 0.68 is less than 0.95. And we're done there. The weights of 8 newborn babies are recorded in the table as shown below. So here's the table, and then on the grid, draw a scatter graph to show this data. So for part C, we have to draw a scatter graph. So remember, that just means weight, check where that is, up the side, length must be down the bottom, and I'm just plotting points the best I can. So 2.7 and 46, 2.7, Well, it's going up in ones, so that's 2.7 there. So I'll just put a little dot. Tick it off as I go. Then 47 and 2.8. So there's 47, 2.7, 2.8. Tick it off. 49 and 3.5. So there's 49, 3.5 will be here. Tick it off as I go. 51 and 3.7. So I go to 51 and I go up to 3.567, making sure I'm being as accurate as I can, taking my time. 52, 3.4. 52 and 3.4 will be there. 52 again, but this time 3.7. So on the same line, 3.567. There it is there. 54 and 4.0. So 54 is the second last one. So there's 4.0 right there. And the last one, 55 and 5.4.4. 55 is the last place. 4.4, 1, 2, 3, 4. And we get a completed scatter graph like so. Part 2, draw a line of best fit on your scatter graph. So I'm going to need the ruler for this. So there's my scatter graph, and it can't go through every single point, so I'll just make it so that at the very best I get the points are equal distance away from the ruler line either side. That's a good line. It doesn't have to be exact, and it doesn't have to go through that first point. If it doesn't, it doesn't. If it does, it does. I'm going to say about there, maybe a little bit more, is a good line of best fit. And I'll just draw my line in nice and neat. And you get a line of best fit. Either, as long as it doesn't join the dots and it isn't obviously way off, you'll get the marks for this. Use your line to estimate the weight of a baby who was 50 centimetres when born. So I need to find 50 centimetres. So let me just make that a little bit neater. So I can do this showing you by highlighting this 50. I go up to where it joins the line and then read off the mark. Now the best thing to do is actually get a pen, different colour, and literally get a ruler and join that up. Now I can do that without any bother, and then do the same on this side. And you can get a nice close enough answer of 3.123. So I write 3.3 and the answer's in kilograms. And we're done there for the scatter graph. Huge question. This one, question 7, continues that baby milk is sold in 900 gram packs. The feeding guide from one of these packs is shown below. Each level scoop contains 4.5 grams of milk, and baby Andrew weighs 7.1 kilograms. Determine whether a 900 gram pack of milk powder will last Andrew 1 week. So this is reading information off a table and then doing some sums with it. So let's have a look. First of all, it says approximate baby weight in kilograms. So I know that Andrew weighs 7.1, so I need to find where he is. Well, that's between 6.5 and 7.5, so I'm in there. So let's take a note of that. I'm there. And then number of feeds per 24 hours is 4. Number of level scoops per feed is 8. Quantity of water per feed is 180. And fluid ounces. So we don't need the water. The water is irrelevant to the question. It's just there for extra information. What we need to know is the weight. So we've got 4 feeds per 24 hours and 8 scoops per feed, so times 8, and 4.5 grams of each scoop. So that's how much you get in 24 hours. And then we've got a week. Well, 24 hours is a day, a week is 7 days. So I need to times that whole thing by 7 and see what I get. 4 times 8 times 4.5 times 7 is 1,008. So that's 1,008 grams. So will the milk powder last Andrew a week? No, as 900 grams is less than 1,008 grams. And we're done there. Thanks for being asked 5 applications of maths, 2019, paper 2, question 8. A new road bridge has been built. A worker paints 367 lines across the centre of the road. Each line is 4 metres long. There is a gap of 2 metres between each line. The first line starts at the beginning of the bridge and the last line at the end, find the length of the bridge. So imagine with this one, in terms of gaps, so there's a line, and then there's a gap in a line. So for 2 lines, there's 1 gap. For 3 lines, there's 2 gaps. For 4 lines, there's 3 gaps, and so on. So that means that if I've got 367 lines, there must be 366 gaps. And the gap is 2 meters for the gap, and each line is 4 meters. So I need to then work out 367 lines times 4, 366 gaps times 2. And then add up my 2 answers. 1468 for the first number, and 732 for the second number. Adding them together gives me 2200. So the length of the bridge is 2200 meters. 2 cables support a section of the bridge. The section forms 2 right-angled triangles, as shown in the diagram. Calculate the total length of cable needed for this section of the bridge. So I need to work out this length cable, and I need to work out add on that one. Now, to get this one, I need a right-angled triangle to do Pythagoras, but I'm going to need the height. I don't have it, but I can use this triangle first. So let's call this bit A. Then A squared equals 300 squared minus 295 squared, because Pythagoras, opposite a right angle, is the longest side. So when I've got the longest side, I take away. That gives me 2975. We're going to 2975 is 54.54. So that means A equals 54.54. That's our height. And that's in meters. So now we've got the other triangle, which is on the left. And that is 54.54. And that is 600. So if we call this one C, then 54.54 squared plus 600 squared equals C squared. So this is now an adding Pythagoras because I'm finding the longest side. We already know that that squared is 2975 plus 600 squared gives me 362,975. So C is the square root of that number. And that is 602.474. So now total length of the table is just that 602.474. So we do 602.474 plus the 300, 902.474, let's just call it 47 to 2 decimal places and be done there. It's been answer 5 applications of Maths 2019, paper 2, question 9. David is writing his new book. He spends 210 hours on research, 96 hours of meetings, and 234 hours writing the book. We have to construct a pie chart to illustrate this information. So for a pie chart, we need to work out our angles, which are just using fractions out of 360. So the first thing you do is work out the total of all the things that are happening. So getting my calculator, I'm just doing an add sum. 210 plus 96 plus 234 is 540. So my total is 540. So if I make a little table at the side here, I've got, let's call it research, meetings, and writing. We know our angle's 540, so to get our fraction's 540, so to get our angle, it is the number out of 540 times 360. Now it's a calculator job, so you just do top divided by bottom times 360. So 210 divided by 540 times 360 gives me 140 degrees. So our research is 140 degrees. Our meeting is 96 divided by 540 times 360. That gives me 64 degrees. And finally, our writing, 234 divided by 540 times 360 is 156. So now you get all your angles. You could double check and make sure that these do add up to 360, and they do, so you've probably done it right. And then we need a protractor. Okay, so I've got my protractor to measure my angles. So how this works is we're going to start off with this line that I've already drawn for us. I would draw that if I didn't have it. There's the centre. I'm going to measure around as I go. I'm just going to do it each one at a time. So the first one I'm going to do is 140. So I take my protractor, put it in the middle, make sure the X lines up with the middle, and I'm going to zoom in here so you can see. I'm trying to do 140. So making it nice and big. That right in the middle. And then we're just going to count around 140. So we notice it's going through this 0. So we're counting around 140 on the outside scale, which is way down there. So you're going to put a mark down here so you can join that up to the middle. So now you just get your ruler, join that up. You see the little mark you've already made. We'll zoom in a little bit so you can see it. Make sure you join it right up and it's going out the outside. Get your ruler and draw it nice and neat up to there, right up to the end, and we're done. So that's me now done my first section, which we can label. That was for research. So we'll just label that research. We don't forget, and we know this angle here was 140 degrees. Next one is meeting. So again, we start at our new line and we measure around 64 degrees. You get your protractor, turn it around the right way, do it right on the corner, make sure everything lines up through the middle, through the 0. Get it as best you can. There we are there, that's good. Remember, it was 64, we check what scale we're going through. This one's still going through this 0 on the outside, so I'm going to round this way. So I'm going to round to 64. There's 60, 65 is a big line, so 64 is about there. So then I get my ruler and join that up. Mark, just getting it as nice and accurate as I can. There we are, we're going through that line. So we'll just get our pen and follow our ruler to the middle. And we get rid of our ruler and we can see that we've then got this bit here. So that bit was called meeting. And the angle we measured was 64 degrees. Now, we don't need to draw another one because there's only one left, but we can check that it makes 156 or as close as we can. So let's just get our protractor and do that. So putting the protractor in the middle again. Lining that up through the 0. You should be able to see it's meant to be 156. So it's going through the 0 down here on the bottom. There it is there. So I'm going to outside scale again. And I'm 155, 156. Close enough. I mean, my protractor's probably off a little bit. This is on an iPad. But it is, I'm pretty happy with that considering that's on an iPad. If I just move that a little bit and move that centre in a little bit, you should be able to see I can get closer to 156 just by turning it out slightly. And there we are, that's more towards 156, still going through the 0 there. So I've done it, it's pretty accurate as I can. You want to be out within a couple of degrees. So if you can do that, you're good. Then we get rid of this protractor and label my last bit. So the last bit was called writing. So I want to call that writing. And I put my angle in just for the sake of it. That was 156 degrees. And then for number of people, that was worth 210. The meeting was worth 96. And it was 234 on the writing. Number 9 continued. A publishing company produced the following table to show all the tasks involved in publishing a book. Complete the diagram below. So we've got this is called a PERT chart, which you'll learn if you ever do higher, or an activity network. So we're starting off with, this is a little bit more complicated than normal. We look for the preceding task is none. So the first one we're going to write is C on the left. So that goes there. Just tick it as we go. And then we look to see what comes after C. So we're looking on the right hand side. Then what comes after C is this one. So I'll read it off. That's B. So B goes here. And now we've got a choice. And the choice will go 3, then 2, then 2. So after B, we've got edit book, and then after edit book, we've got rework, and then after rework, we've got proofread. So you can see that that one is the 3. Now, if you don't see that straight away, just do it. Go back if you make a mistake, but I can see it straight away for the purposes of this video. So after B is D. So I'm going to put D in this one. And then after D is F. So I'm going to put F in that one. And then after F is G, so I'm going to put G in this one, and then go back and see what else is after B. So after B is here, which is H, so I can put that here. And after B is I, so I can put this one there. And then check what's after H. Well, there's H way up here, which is A. And then after I is J. And then just double check AJ and G, AJ and G lead to E. So I've done the full chart and I'm done there. Okay, question 9 continued. The books are to be backed into boxes for transport to the bookshops. The dimensions of the books and the internal dimensions of the box are shown below. The books need to be labelled so the front cover's facing up the way. Calculate the maximum number of books that can be packed into each box. So this is a box packing question, and usually we will limit it so you don't have to do all the options. But essentially, here's how I do this. I draw a little table for myself. And we're going to do all the options we can do. So let's just call this option 1. So big box goes first. So I'm going to call that the length, the breadth, and the height, just to give it a name. So we'll put the length, the breadth, and the height. And the one that has to be fixed is the height, because this always has to be on top. So I can only turn it around, but I can't flip it over. So I'll take a note on my little chart that this one's never changing. And now you just put lengths against lengths. So option 1, now first of all, actually, all the lengths are different. So let's change them all to the same. Let's make them all centimetres. So that's 100. And then millimetres was 10 millimetres in a centimetre. So divide by 10. So that's 19.5 centimetres. That's 12.5 centimetres. And that's 2 centimetres. Right, so now we can start. So let's start off with the length of the box. It's always the big one divided by the small one. Length divided by length. So 19.5. And then we can go breadth, which is 50, divided by the breadth of the box, which is 12.5. And then height against height, 20 and 2. So there's option 1. And I'll work out the sums in a minute. But we could also have an option 2. Now notice we said this could never change. So that sum stays the same. So it's still 20 divided by 2. The length and the breadth of the box is still the same. So big box is still the same. But I can now move the small box. That's the small one here. If we call that big and small, you can see that. And all you can do is just swap the numbers. So that one just goes here. And this one just goes there, just swapping them around. So I've got 100 divided by 12.5, and I've got 50 divided by 19.5. Now, when you're working out these sums, you're rounding down because it actually has to fit. So you can't round up because it wouldn't actually fit. So I just get my calculator out. 100 divided by 19.5 is 5.128. So I just write about 5. 50 divided by 12.5 is 4. And 20 divided by 2 is 10. For the other option, I've got 100 divided by 12.5, which is 8. I've got 50 divided by 19.5, which is about, tiddles, little tiddles, 2, just rounding down. and 20 divided by 2 is 10. Now, how do I know which one of these is better? It's just times them. You just times all your answers together. So for this one, 5 times 4 times 10. Using a calculator, 5 4s is 20, 20 times 10 is 200 books. Can fit inside that box. But this one, I do 8 times 2 times 10. 8 2s is 16 times 10 is 160 books. So the maximum number of books I can fit in is 200. So I'll just write that down. Max number equals 200 books. And I'm done there. Okay, question 9 continued. This is the 4th book that David has written in this series of books. The cost of each book is shown in the table. Book 1, Book 2, Book 3, Book 4. The following special offers are available to buy all 4 books. Shop A, buy all 4, get 20% off. Shop B, buy all 4 for $22.99. And Shop C, buy all 4, get the 2 most recently published half price. Which shop has the best deal? So this is the best deal or best buy question. So we need to work out the price for all 3 shops, but B is already given to us. So part A, Shop A will do first. So for Shop A, buy all 4, save 20%. So I need to add up all 4. So total cost, let's just write the sum, £5.50, £8.50, £4 and £12. Use a calculator because we're on a calculator paper. £5.50 plus £8.50 plus 4 plus 12 gives me £30. And it says save 20%. So I need to take 20% away. So 20% of £30. There's a couple of ways to do this. It's a quick way, but I'll just do it the short way. 20 divided by 100 times 30. So you save £6. So the cost is 30 minus 6, which is £24. So there's Shop A. B, we already know is just £22.99. So we don't need to do anything. So that's so far the cheapest, but we need to check C. Buy all 4, get the most recent, we published half price. So we know the total cost, if you buy all 4, would usually be £30 because we've already done that. And the most recently published half price, so we've got this one and this one, 4 and 8, 4 and 12. So discount, 4 plus 12, but then divided by 2 because you get them half price. So you get an £8 discount. So that means that it actually costs 30 minus 8, which is £22. So there's my 3 answers. The cheapest is Shop C. So I should go to Shop C is cheapest. And we're done there. Screen answer 5 application maths 19, paper 2, question 10. A sports ground is in the shape of a rectangle and 2 semicircles is shown. Running track is shaded in the diagram. Calculate the area of the running track. So if we look at this one here, we could do the area of the whole thing minus the area of the whole. Or what we could do instead is just do our circle part minus this circle and then just add on the 2 rectangles. And that's the approach I'm going to take here. So let's look at our circles. We've got 1 semicircle on this side and 1 on that side. So in total, we've got 2 whole circles, a big circle and a small circle. So I'll do the big one minus the small one. From the start of the exam paper, the area of a circle is pi r squared. So I'm going to need the radius. So let's get a calculator and work out the radius of the big one. So the radius for this one is going to be half of that. 90.7 divided by 2 is 45.35. And then for the middle bit, I've got 73.6 divided by 2, which is 36.8. So in this bit, I could write 36.8 meters for both of them. So then it's just the area of the big circle minus the area of the small circle. So that's pi times 45.35 squared minus pi times 36.8 squared. Now, we could do these sums separately and then get our answer, or we can just do brackets around them both. So I'm just going to do brackets just to quicken this up. So get my calculator, bracket pi times 45.35 squared, close my bracket, minus bracket, pi times 36.8 squared, close the bracket, press equals, and you get 2206.599. 2206.597 meters squared. So that's my circular bit done. So now I need to do my rectangles. So for my rectangles, I've got this length times this length. And I've got two of these rectangles. So I need to identify the length and the height. So to get the height, you've got all the way up minus this bit, but then I need to divide by 2 because there's two sides of this. So 90.7 minus 73.6 divided by 2 is the height of each rectangle. And that gives me 8.55. So now for my rectangle, I've got 8.55 here, and I've got 84.4 here. So the area of that is 84.4 times 8.55, but I've got two of them, so times 2. 1443.24. So I've now got two areas. I've got the area of the circular parts. I've already took away the holes, and I've got the area of the grey rectangles, so I can just add them together to get my final area. So total equals 2206.5997 plus 1443.24. That gives me 3649.839, or 3649.84 would be fine. 3649.84 meters squared. And there's our final answer there. And we're done there. The running track's to be resurfaced. The resurfacing company has a team of 5 workers who can resurface the track in 42 hours. A resurfacing company is now able to add 2 more workers. All the workers work at the same rate, calculate time to resurface. So this is inverse proportional, reverse proportion. So 5 workers, I'll write that down, take 42 hours. Now, if this was like 5 sweets cost £42, to get 1 sweet I would divide by 5. But when work is done, you do the opposite. So I times to get 1 worker. So for 1 worker, I get 42 times 5, which again, using a calculator, would give you 210 hours. So then to work out 7 workers, usually I would times by 7, but I'm doing the inverse, so it's divide. I do 210 divided by 7 workers, which is 30 hours, and we're done there. John works for a resurfacing company. His annual salary is £17,108, £17,108. National insurance is calculated on a person's salary before deductions, such as pension. Calculate John's national insurance payment. So I've got this national insurance here, here, and here. It's calculated before deductions, so I take it on his full salary. So I do it bit by bit. So in the table, 0% means I'm paying 0. And then for this bit, if he earned above this amount, I would do this minus this times 12%. But he earns just this amount, so I do that, 17,108 minus 8424, and I times by 12%, which is the same as 0.12. So in a calculator, you can do that in one go. Using brackets, 17,108 minus 8424, close the brackets, times 0.12, and you get 1042.08. 1042.08 pound sign, and we're done there. John pays 7% of his annual salary into his pension. His annual tax is 105,160. Calculate his net pay. So his net pay is taking his pay, take away his pension, his tax, his national insurance. So I need to work out his pension. So for his pension, I do 7% of his salary, which was 17,108. So in a calculator, 7 divided by 100 times 17,108 is 119,756. So his net pay is equal to 17,108 minus the 119,756 minus the tax, which is 105,160, and minus the answer I just got for his national insurance, 104208. So doing all that in a calculator, 17108 minus 1197.56 minus 1051.60 minus 1042.08 is an answer of £13,816.76, and we're done there.